Okay, so we're looking at complex numbers, and we have to just remember that a complex number has a real, that's a regular number, and an imaginary. Okay, it has a real and an imaginary. So as long as we set it up so that our answer has a real and an imaginary in our final answer, all we have to think of this is combining like terms. So when I look at that, I'm going to have to deal with this first, actually. I look at this and I'm like, that negative is going to be distributed. So let's do that first, and then we'll see what we combine. So we get negative 3 plus 6i. Negative times a negative is a positive. Negative times this other negative is also a positive. So all those signs changed. Now, all I have to do is remember, I need to just put this combine like terms and just put it with the real out front, the imaginary following. So let's see, what are the real numbers? Negative 3, 5, that's it. And what do we get when we combine negative 3 and 5? We get 2. Done. Cross them out if that makes you feel like you'll keep track of everything. And then the other one is 6i, 3i, 8i. So we're going to add together 6 and 3. That gives us 9. So we have 9i between these two. 9i minus 8i is positive 1i. Okay, that's it. And you know what? I think the first 8 problems were similar to that. Okay, anybody else want to see one of these from the worksheet? We got number 7 down. Or are there any questions coming up on number 7? I feel like that's one where I just have to show you how to do it. And then it becomes that much easier. Oh, let me put something real quick. Okay, in the chat, let me know what else do we have? What else? All right, anybody? 7, and I could just do one. Let me just do one. There you go. Let me know. Well, I'll start to pick them then. I'm gonna do 3 more problems. Let's do number 9. Number 9 is 4i times negative 2 minus 8i. And this is where my identities might come in handy, just to have them here. You don't have to have them. I'm not going to make you memorize these. I'll probably have these available on the test. Okay. That's not the standard we're working with. All right. So when I combine these, I'm going to end up with some exponent greater than I to the first power. So I'm going to keep these handy so that I can just keep that in mind. Let's see. So we're going to end up with negative 2 times 4i, and then 4i times negative 8. We're going to have negative 8 times 4i. Good. And then here, negative 2 times 4i is a negative 8i. Negative 8i times 4i is going to be a negative 32i squared. But then I look in this, and this is why I wrote these identities over here, because once you figure out, this is ready to combine or simplify. So now that we have it at this level, we can look and see, do we have any I squares? Because I know that always equals negative 1. I to the third is always negative I to the fourth is equal to 1. On my YouTube channel, I have a whole lesson on breaking this down if you wanted to learn that or it's confusing. Okay. So let's search on my web, search for the I will. This comes from the I will. I think I named it the I will. Okay. Online, you can find it on my channel. I squared is equal to negative 1. So look what we have. We have negative 8i minus 32 times negative 1, because those identities we can count on. We can count on them. So I'm almost done. Plus 32, but there's one other step. Remember, the real comes first. then imaginary. So they're just not in order. Now they're in order. Done. Yep. Yep. Yeah, pretty smooth. All right. Then I'm going to jump down to let's jump down to 13. Oh, God. -2 minus I. Wow, this class goes so fast. We got 12 minutes. We could do it. -2 minus I times 4 plus I. Remember, if it was just -2 times 4I, right? If it was just -2, if I hit it with my eraser here, then all I would do is multiply -2 times 4 and then -2 times I. I would just distribute it. All I have to remember when I have binomials, two terms in that first one, then I have to do as if I just had -I and I need to multiply those to each of the terms. So I'm going to do them one at a time. Let's do the green first. -2 times 4 is -8. I've done that one, so I'll cross it out. -2 times I is -2I. I've done that, cross it out. -I times 4, -4I. Done that, cross it out. -I times positive I. I'm just going to write that because that one's going to be a little weird. Okay, let's combine what we can. I haven't done this part over here yet, but I know that I can combine those. So let's just rewrite it, combining those. -8 minus 6I. And now let's deal with this. Because -I times another I is -I squared. Essentially, this right here is -1 times I, right? I can split it up like that. And that is going to be -I squared. So that's how we got to this step. Now, remember, it's -I squared. What was I squared again in our identities? -1. I squared is -1. The four identities, maybe jot those down real quick if you haven't yet. Let's see if I can do this. Oh my God. I can do it. So we had -8 minus 6I minus I squared. We know that that is equal to minus -1. Okay. So let's see. -8 minus 6I plus 1. Combine your like terms, real out front. Put the real out front. Done. Okay. So it's a combination of using what we learned in the prior section, and also just memorizing these four identities for imaginary numbers. That's a good one there, I think. This isn't for this section. Cool, let's do a couple of those. Actually, honestly, this is as hard as it gets for this worksheet. So if you can understand that's actually a pretty good example problem. All right. Someone is requesting another look at our factoring power up. So let me pull that up here and I'll do a couple problems. So that was numbers 9 and 10. Let's see about it. All right, here's number 9 and 10. Okay, I'm going to pull this back. So if you needed a screenshot of this first page, I'll pull it back for you. And go ahead and grab a screenshot. You got 3 seconds for a screenshot. If you don't know your screenshot quick keys yet, you got to find those quick keys. You got to know the keys. That's going to be super helpful, guys, screenshotting. All right. Let's look at our last bit. This is just looking at a couple of factoring problems from our first factoring power up we did. All right. Yeah. Ooh. Alicia, was the answer at the bottom the issue? When you look down here, you're like, oh, crud. It was, no, we can do this, right? We can do this. We can do this. Watch. All I have to do is break up all of these parts. I know that's 5 and k squared. That's kk. So we have 5k and k. When you're done, put a 1. Next, we have negative 40k. We're going to break that up. I like to break up the negative right off the bat because I like them separate. Geez, this is going to be a long one. 220, 210, 25. That's faster than I thought. Whew, there's a lot of those. Let's see. We got a 5. We got 2. We got 2. We got 2. We got a negative 1. We got a k. When you're done, put a 1. I did that in a little different order. That's fine. And I see 10. I know that's 5 and 2. All right. All right. All right. Now remember, we're going to put our parentheses down here because leftovers. Leftovers. GCF is on the outside, leftovers inside. What's left? Clarify, Maya. Not sure what that means. 5 is in common. 5 goes out here. Okay. Alicia, here's the key. These, whatever's left over, multiplies straight down. I should have put a 1 there. Multiplies straight down. That's what's left over in the term. Everything for these is multiplying and dividing. Everything. So I look here. This is k times 1, k squared. This is 2 times 2 is 4, times 2 is 8, times negative is negative 8, times k is negative 8k. Okay, no problem. Let's see, the last term, 2 times 1, positive 2. Done. All right, okay. Who feels good about factoring? Yeah? Okay, good. Shall we do 10 then and call it a day? Yeah. Alicia, do you want to see 10 as well? 10. You got it. 10. 10 is 63 m to the 6th minus 49 m to the 5th minus 21 m. Hey, don't worry if it's m, if it's k, if it's p, if it's z. It does not matter. It doesn't matter at all. So I look here and I have 63 m to the 6th. 63 m to the 6th. I'm just going to say it's 6 m's. Okay, I don't need to make a branch that big. 7933. Seven, three, three, m, 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 m. 1 put a done. Done put a 1. 1 put her done. That's not right. Negative 49 m to the 5th. I like to get that negative out of there. 49 m to the 5th. Let's make this 49 and m to the 5th. 7, 7. 7, 7. Negative 1 and m, 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 m. Done, put a 1. Negative 21m. Negative 1 out there. I don't like the negatives, so I break them out quick. All right, we got some factors there. We got 7 and 3. Done. So what do we have? 7, 3, negative 1, m, 1 put a, done, put a 1. Ugh. All right, leftovers are going to go here. GCF is going to get out of there. All right, let's see. It looks like I have a 7. It looks like I have no more numbers, but I have an M. Oh man, that's it. A lot of leftovers. This is like you make a big old meal for your family and everyone's already eaten all the cake and they're not hungry. So you have leftovers as your main meal. If it's good food, I'll eat leftovers every day. It's fine. All right, multiply what's out there. 7m. Bring down everything else to our 3 spots for them. All right, let's see. 3 times 3 is 9 times 1, 2, 3, 4, 5 m's is 9m to the 5th. Next, 7 times negative 1, negative 7. 1, 2, 3, 4 m's, negative 7 m to the fourth. Finally, 3 times -1, -3. Yep. Hey guys, I know it's really bad that I'm a teacher and I don't know, but I forgot. Wednesday is Veterans Day, and we have it off. We have a weird space in the middle of the week. You've gotten that update? I wasn't sure. Yeah, okay. So Wednesday, there's no class. That won't affect you because I'll see you tomorrow. But if there's any other scheduled things for Wednesday, I'll keep it unless I hear otherwise. Okay. So let's see. Well, that's all. That's all of the homework for kind of like what was recent. So I'm gonna go ahead and stop the video and